And give it up for Nick Galloway.
Hi. Okay, we're gonna hold it there. Okay. Hi, I'm Nick. I'm gonna talk to you today about styling with JavaScript, hopefully a decent introduction to CSS in JS. So this is me. That's my Twitter handle if you want to find me or follow me or talk to me. So a little bit about me. I graduated from UIUC here, computer science in 2015. I've worked with Angular, React, and Vue at different points. I'm currently a software engineer here. I sit in the back over there. Currently working with React, Redux, Node, and Webpack. So let's start at the beginning of CSS. 1996, spec came out. Basically, the basis of reusable styling on the web, pulling your styles out from inline and making them reusable across different components. But it quickly becomes unruly as web applications start to get bigger. So in 2006, we get Sass, which attempts to kind of wrangle that with adding a semi-programming language on top of it, adding nesting, variables, mix-ins, extending logic to your styling. But as web applications begin to grow even more, we get class name clashes, where we start to get a componentized approach to web development. We start to have the issue of like maybe our sidebar has a header, maybe our main component, our main content has a header. Those classes will clash. So this invents a convention of using namespaces that are hopefully unique. So it looks like this. If you've never seen it before, it's block element modifier, where this is showing a disabled submit button inside a form, where form is your block, submit is your element, and disabled is your modifier. And then you can style it with Sass below there. So that works all right. Then around 2014, we get CSS modules, which attempts to solve this problem by using tooling over convention, because relying on developers to do this can be a little hairy. It can be a little bit cumbersome, and the init class names get a little bit long and a bit of a pain to deal with. So CSS modules allows you to write your class names as you normally would, and then it just attaches a unique ID to the end of them. This is done at build time with your Webpack grunt gulp builds. And then the usage, because you obviously don't know your class names at development time, is that you import them and then use them as you would as an object and just grab the class names off of them. So around the same time in 2014, you get CSS-in-JS start to gain a little bit of traction as well, which attempts to solve the same issue that CSS module solves, which is using tooling over convention. But it also has the added benefit of giving you the full power of JavaScript behind you, where you can do some really cool and dynamic things when you're styling. Finally, around 2016, we have a subset of CSS-in-JS start to come about called styled components, which so far is the pinnacle of the CSS evolution. The goal of it is to eliminate the need to even use class names, because you're declaring them in a file, you're exporting them, you're importing them, and then you're attaching them. The idea is to wrap that all up into one thing that you can just pass it to a function, and it'll give you back a reusable component that you can pass around in your code. So that's how we got to this point. What is CSS-in-JS? Simply is writing your CSS inside your JavaScript, and then JavaScript will handle mounting the CSS to the DOM, and then the browser will handle rendering that as normal. So to demonstrate it, let's build a very simple button component that has default and primary. Hopefully you guys can see that in the back, but trust me, it's as simple as it looks. And then with React, you would just do this as normal. You put your class names on there, and then whether or not it's primary or default depends on your primary prop. Doing this in CSS-in-JS should look very similar. You're just bringing in a CSS function from your favorite CSS-in-JS editor, and then writing those styles in a template string, and then attaching those down here at the bottom with template string interpolation. Because it is also attaching a unique ID onto those class names, so again, you don't know those at development time. Some libraries will use objects instead of strings. So you'll get this camel case style. The benefit of this is that you can get some type checking going, and you can get some CSS key validation going. So if I accidentally type board-e radius, most editors and most libraries will give me a heads up that that's not a valid CSS property. So I can go ahead and fix that. Now the advantage of strings over that is that you're writing basically CSS. There's no need to learn anything new, and it's very portable from a non-CSS-in-JS solution, a normal CSS solution, to a CSS-in-JS solution, since the syntax is the same. Finally, some libraries will even allow you to do what I mentioned before as styled components here. So you'll bring in your function from your favorite CSS-in-JS solution. You'll pass it the HTML element that you want. In this case, it's a button. And then you'll give that a function that'll take props, and then you can dynamically style your component based on those props. And that will return to you a button component that you can pass around. There's no need to handle a class name at all. Under the hood, it may use class names. Most of them do, but you as the developer don't have to be concerned about it. So what are some of the benefits of using a CSS-in-JS solution? You have the full power of JavaScript at your disposal. This is basically the #1 reason. You get everything that JavaScript offers: functional programming, browser APIs, internationalization, the debugging tools that JavaScript offers. Those are all at your disposal when you're writing your styles. And you already know JavaScript. You poured hours into learning it. You don't have to learn Sass, Less, Stylus, these other solutions, because you already know JavaScript. You know the intricacies. You know how to manipulate it to do what you need it to do. You can use variables already defined in your components when you're computing your styles. For example, let's say you have to style part of a component based on the computed width of another part of the component. This is something you've already computed. It's already in JavaScript. Styling that could be a huge pain, but you already have that value in your JavaScript. You can go ahead and just use that when you're styling. Another example is dynamically styling a component based on the return of an AJAX call. You have this value available to you in JavaScript. You don't in CSS. Another benefit, your builds process for tree shaking will automatically eliminate unused classes and class names. CSS modules and post-CSS have build tools that allow you to do this, but you don't have to if you use CSS-in-JS. It's automatically part of your build process if you use tree shaking. You may be able to eliminate building CSS entirely, simplifying your Webpack build, and speeding it up significantly. In Webpack 3, the extract text plugin is notoriously slow. So being able to just pull that out and use JavaScript to do it is much faster. You can even unit test your CSS if this is your thing. Because it is JavaScript. You have Jest at your disposal. You have Mocha at your disposal. It is available to you. So those are upsides. Let's talk about downsides a little bit. There's possibly a learning curve. This is an issue that's brought up with me. I don't necessarily agree with it, but it is something that people bring up, so it is something to be aware of. If you're using strings, there isn't much of a learning curve. You're just writing normal CSS. If you're using object notation, there may be a little bit more claim to this because there is a little bit different syntax you have to learn. Another downside is it may be harder to share styles with teams that aren't using a CSS-in-JS solution. If you need to give them your styles or they need to give you styles, if you're using specifically object notation, it could be a bit of a pain to convert that back and forth. And if you're using a reusable library, in a lot of cases, it's better off to just share the components instead of the styles, because CSS-in-JS will allow you to not have to bring in styles and render them in your Webpack builds. It won't require you to bring in an external style sheet. The components themselves will just handle the styling of themselves. It's very popular with a lot of component libraries for that reason. This is definitely something to be aware of. If you're using styled components, you're usually tied to React. If you don't want to be tied to React, that is a very valid reason not to use it. Debugging may be difficult if you use randomly generated class names. A lot of these libraries allow you to attach a debug name, or if you pass it an object with keys, it'll use those as your debug names. But just be aware that if you aren't making sure that the generated class names have debug names on them, when you open up your debugger and are greeted with a bunch of randomly generated class names, you have no idea where they came from. It's just pure hell. This is also something to be aware of. There is a small performance hit because your styles are now computed by JavaScript. So you get a bit of a waterfall effect where the JavaScript needs to come down, be rendered. The styles are mounted to the DOM, rendered by the browser. So you will get that performance hit. You can avoid it using server-side rendering or embedding critical CSS in your head, which is always good practice regardless of whether you're using this or not. So I wanted to propose, I use a bit of a hybrid approach when I generally use this, which is that I use like Tailwind CSS or utility class library. It's pre-built, it sits alongside my app, and it's in normal CSS. Then I use a CSS-in-JS solution for edge cases when I'm building my components. This has generally worked really well for me. It gives me the full power of JavaScript when I may have weird edge cases that I need to handle. But for most of the time, I can write components without writing any CSS because the utility classes should be taking care of most of those situations. So those are the benefits and the downsides. Let's talk about what's available to you. First, you have to decide what you want your library to generate. You have three options. It can generate class names, it can generate components, or it can generate inline styles. Some of them also do a combination of these. You also decide how you want to write your styles because some of them only offer you to write it in template strings. Some of them force you to write it in object styles. Some will offer both, but it's rare. So let's talk about some popular solutions. We have TypeStyle and Aphrodite for class name generators. These are libraries that you give them your styles that return to you a unique class name to use on your components. So TypeStyle attempts to make CSS as type safe as possible. And that's its biggest sell. It is pretty good at that. It also supports adding raw CSS for a bit of an escape hatch when you just want to do some styling of, let's say, like the HTML tag. You can do that with this. Aphrodite is a bit of a unique one. It allows you to compose your classes from utility styles. So let's say you declare a red style that has like a color of red, and then you declare a bold style that has a font weight of bold. Then in your component, you will have a class name where you give it the Aphrodite CSS function with those styles as arguments. And that will generate a class name for you from those styles. So it very much embraces that utility class style of styling. And it's a bit unique in that way. So then we have popular component generators. The king of this is styled components, which pioneered the idea back in 2016, specifically built for React. And it is still the standard for styled components. It is very popular. It is very robust. It has a lot of features, and it has a lot of GitHub stars, if that's your thing. Styletron is an alternative to styled components. Basically diving into it, the one thing I could find that separates it is that it uses objects for styling instead of tagged template literals, which is what styled components uses. Again, the advantage to this is you get some CSS key validation and type checking along with that. So there's also ones that allow you to do class name and component generation, starting with Emotion, which is a very powerful and performant one. I believe as of recent numbers, it's one of the most performant at its size, at what it offers. It builds on the best of its predecessors. It has some of the best of styled components, some of the best of these class name generators. it really does have a performant and powerful solution. It also supports adding global CSS for that escape hatch. JSS has a fantastic selection of plugins, including having that escape hatch, but it also allows you to plug in all sorts of advanced things. It specifically allows you to plug in Aphrodite. You can use it just as you use Aphrodite if you bring in that plugin. Styled components, it has that as a plugin. It has a fantastic selection of them. It also, as far as I could tell, provides by far the most fine-grained control over how and when your styles are rendered. So you can actually tell it when and how you want your styles rendered, which none of these libraries seem to offer you that fine grain of control. It also allows you the option of registering your styles with a registry or passing them around your app, depending on how you wanted to do it. Linaria is a bit of a unique one. It's still in alpha, but it is a unique idea, which is a zero runtime solution that basically does a build time server-side render that will run through your code and build a CSS file for you at build time. And because it does that, it also supports CSS extraction or critical CSS extraction into the head of your document. Finally, we have CXS, which is zero dependency, very small, very fast. I can attest to both of those things. I've used it before. And it's light, it's easy to learn. It's a single page README that explains the whole thing. It's definitely something to consider. Finally, we have popular inline style generators. As far as I could tell, Radium is still the king here. Specifically built for React, particularly popular with the component libraries because it doesn't pollute your class name namespace with class names because it doesn't generate any class names. It's able to overcome inline styles by using a watch and swap approach. Those limitations being like you can't do media queries, you can't do hover states. Basically, it attaches listeners onto your elements and then will swap styles out as events happen. Ultimately, it's a lot of information to throw at you. The idea was just to give you an objective view and give you some information about CSS-in-JS and ultimately choose what works best for your project and your team. Thanks.
Thank you, Nick. That was, wow, you know, I thought it was amazing when we could no longer write HTML and we could just write it in React, but now we don't have to write CSS. We just write that in JavaScript too.
It's pretty cool.
Thanks again. So coming up next, we have Pranay. He's going to talk to us about async generators. Are you connected to the